Hi, my name is Adrienne Walcer. I'm a technical program manager at Google, and I'm joined today by Mr. Alexander Perry, who's a site reliability engineer. And we are here today to talk about organizational design for technical emergency response. So our team builds fire trucks, not like literal fire trucks. Fire trucks on their own don't resolve emergencies. Fire trucks are vessels that help resolve emergency situations and facilitate critical mitigations during disasters. So that's what our team focuses on. Disasters. Undesirable events that lead to severe consequences. So we look at a wide variety of potential crisis scenarios, including embarrassing technical bugs, wildfires, alien invasions, political insurrections, drought, global pandemics, and the occasional cat that breaks into a data center, wrecks a transformer, and causes a full power outage. But back to embarrassing bugs, let's take a very blameless look at the Mayan apocalypse. So for Google, the Mayan apocalypse is not some new age phenomenon leading to failure during the year 2012. Rather, the Mayan apocalypse happened on June 2nd, 2019, with a network automation tool named Maya. So Maya does flag management and organizes traffic direction over one of our networking backbones. And a tiny code shift led to an entity type being consistently misflagged. Around noon, we were proceeding forward with planned maintenance. We finalized a list of ops and config changes, including on Maya, to be run over a set number of servers. But when this misflag came into conflict with our job scheduling logic, we discovered a new failure mode in which jobs associated with traffic direction were descheduled en masse. The network traffic to and from those locations then tried to fit the descheduled jobs into the remaining network capacity, where traffic direction was still functional. But it did not succeed. The network became congested, our systems correctly triaged the traffic overload, and auto-drained larger, less latency-sensitive traffic in order to preserve smaller, latency-sensitive traffic flows. So the traffic jam had begun. As a result, monitoring kicked off the first step in our incident management process. Alerting. Our monitoring systems noted that error thresholds were crossed. It sent an automated notification to the person on call for that networking component, and they began to assess what was going on. Meanwhile, so fun, the reduced network capacity in affected regions caused spillover. And that network congestion led to cascading failures throughout our networking and computing infrastructure. In general, our network prioritizes our users above our internal traffic, including employees. Now, this is actually fine because we'd rather redirect capacity from the 99.9% of the workforce who can't help solve the problem and use it to do the best that we can for our users. But the 0.1% of employees who participate in incident response usually know how to proceed and sidestep this kind of throttle that we do. But one of the effects of this cascading failure was significant outages of our internal tooling, which disrupted a lot of alerting and led to a huge number of pagers going off. As every on-caller switched into incident response mode, they noticed service unavailability due to networking issues. The network component on call quickly identified the cause of the network congestion, but the same network congestion which was creating service degradation also slowed their ability to restore the correct configurations. Everyone wanted to best support their users and understand the anticipated trajectory of service restoration. So the original network component uncaller suddenly had a lot of company. The widespread dependency meant that no one could really move forward until the network component on-call resolved the issue. Other on-calls began chiming in, offering assistance, and asking questions about when their service would be alive again. The intended parallelism from having so many distinct responders was not providing accelerated mitigation. Root causes and second-order effects began to blur, and one team's cause was another team's effect, and everyone was trying to contribute their knowledge. So while everyone is expert in how their systems work, most didn't really have like a full overview of which tooling paths were rendered unusable by this issue. And why? I mean, paths which never touched the congested network were fine. And paths which did touch were okay if, at that point, the path looked like an external user, because we'd assigned them priority. So services we offered to external users were available a bit, things like video calls and editing documents. But if the path was something fundamentally internal, such as job or flag control or Maya configurations, it was deprioritized and stuck. And it felt like we were watching a volcano erupt, and then 20 minutes later, coming to the conclusion that our issue might be lava related. It wasn't good. So 1 hour into the outage, one component responder noted that the systems issues that were affecting our infrastructure were too pervasive, and coordinated communications surrounding the issue were just turning into chaos and discord. At this point, more than 40 teammates had joined the incident response comms channel, chiming in to try and help. Measuring the impact showed us half the globe. Google Cloud and Gmail and Calendar and Play and other services were affected, preventing businesses from operating, preventing folks from being productive, and preventing people from communicating with each other. Some employees were trying to use the fragmented services that didn't need the damaged network, while others had given up. So what did we do to resolve this incident? Let's break down how we've structured our incident management teams, and then we'll reveal the fun end of the story. So one aspect of the site reliability engineering job is incident response. We set up our organization to provide optimal incident management coverage for all systems. Now, Google's gotten like real big. To serve more than 2 trillion queries per year, we leverage like a lot of data centers, at least 1 million computers, and 80,000 plus people. All of this activity is routed through a massive and highly interconnected system of systems, SOS, critically reliant on its technical stack to be in active production. So the support of this technical stack implies that appropriate personnel are reliably available in order to troubleshoot and correct issues as they arise. And these are the responders in our SRE organization. So when the scope of a technical stack grows beyond one person's capacity to understand and maintain state, we split up that technical stack such that multiple responders can each provide coverage on a single component of the whole stack. Now, as time passes, these components grow more complex and become further divided. By only maintaining limited scope primary responders to resolve issues at any given time, there's a risk of remaining ignorant to production issues spanning multiple components between system-to-system boundaries, or of not providing component responders with sufficient support if an issue proves to be beyond their expertise. We needed a second line of defense that's more holistically focused. So beyond our brilliant group of component responders, we created a second type of incident response duties, system of systems responders. So SOS responder groups provide key advantages when responding to distributed computing failures. So let's start with the basics, component response. Individual component emergency responders will generally have a limited area of responsibility to allow them to maintain a really in-depth knowledge of that area and the enabling systems which can affect it. So these responders are going to be the first line of defense against failures cascading from one component through the whole stack. So these individual components are smaller than the overall SOS stack and usually have clear and distinct system boundaries. So as a result, appropriate monitoring and alerting can be set up, and component responders will be knowledgeable about all of their system's potential failure modes. But when a component responder receives an alert from their monitoring system, it's reflective of a change that has happened within the system they are covering. We have 3 classifications of components. Infrastructure components, like a networking pipeline or a storage service. Product service components, like YouTube streaming or the front end of Google search. And internal service components, like monitoring, zero trust remote access, or Maya and fleet management. And everything in this internal service component bucket was having a bad time. So an underlying fault is cascading through a notable fraction of a technical stack. If this cascade is happening faster than humans can self-organize, it's a really challenging scenario. During an incident with broad impact, we quickly achieve these situations where every component team has been paged, has assigned responders, and are managing their own state. But if component teams are working in parallel, there's a possibility that none of these responders are aware of the others. So one of these incidents might be the root cause, while the rest describe consequences. But which one? Now let's zoom out from individual component response. With a sufficiently large and complex technical stack, there's a lot going on at any given moment. It becomes highly unlikely for a single primary responder to be able to drive mitigation and maintain state on all of their dependencies and their dependents. So to mitigate this risk, we built a structure of secondary responders that are appropriately trained, politically situated, and empowered to lead an organized, coordinated response. So our system of systems responders, SOS. For a subset of incidents, sometimes you need a wider perspective. And oftentimes, these are the incidents that will require multiple teams to address, that may cause or has caused downstream failures. These might have the potential to expand beyond service boundaries, or these are going to be the customer-facing incidents that have been ongoing for more than 30 minutes with no sign of resolution. So we have 2 types of SOS responders that have different functions, but often interoperate. So first, product-focused incident response teams, or IRTs, like the ads IRT or YouTube IRT, are incident response teams in place to protect the reliability of a specific product area. And that product area will encompass multiple potential components and component responders. So not every product area is required to have an IRT, but it's helpful as products continually roll out new features and grow in complexity and tend to have similar scented technical debt. So these are going to be the folks that won't know every single detail of a product stack, but they're folks that are very aware of a product's holistic operations and dependencies. They've generally worked on more than one component of that product and have a really good picture of how things work. And then there's a second batch of SOS responders. Our broadest focused incident response team, the technical incident response team. We lovingly call it Tech IRT. And they are activated for incidents that span across projects or products, have ambiguous ownership, or have an unclear and pervasive root cause. So this team is our last line of defense. So members of Tech IRT are tenured Googlers that have worked as component responders on at least 2 different teams. And they're folks that have a really broad understanding of how things work, and they have excellent incident management skills. So members of this Tech IRT will continue to work for a home component, but often serve shifts on a global 24/7 pager rotation. And they can still work during these kinds of major everything is broken emergencies because they practice this niche skill set a lot. So semi-annually, they have to participate in 2 weeks of production training, which cover the deep details of how things work and fail. And then on a quarterly basis, they need to demonstrate their ability to work productively using only emergency tooling. So it's not so dire as they're sending each other radio signals, but they might as well be. So with each additional level of this incident response organizational architecture, kind of a pyramid, there's an additional level of abstraction from the intricate details of a product's daily functioning. And each role is equally important, and each subsequent level of this pyramid experiences less pager load. If a component responder cannot resolve an issue and it threatens the stability of a product, there's always someone they can escalate to, either a product-focused incident response team or the Tech IRT. Now, if an incident is threatening multiple products, or if a product issue can be more quickly mitigated through a solution on shared infrastructure, then our Tech IRT team will be activated, operating on the broadest scope as a point of escalation for everything below it. But there are some kind of interesting things that enable this organizational architecture to function pretty seamlessly. First, a common protocol. So we widely leverage an internal variant of the FEMA incident command system, in which incident responses have very defined roles, like incident command, scribe, or communications. So by using a shared, clearly defined process, we build positive emergency response habits, including maintenance of active state and a clear chain of command and an overall reduction of stress. Everyone understands who to go to and how to hand off. Like, a chess player can't drop a bishop on a mahjong table and guarantee that everyone sitting at that table knows what to do. So in urgent situations, it's important that all players are playing the same game and know the rules. Things are allowed to move faster. Second, trust. During incidents, incident commanders need to wield authority. They need to direct others, organize chaotic energy, and make judgments about an appropriate course of action. So for many organizations, aligning authority with operational duty is a really challenging concept. But our standard operating procedure avoids the convention that upper-level business directors are the only individuals who should have the authority to make service-altering judgment calls. So we give this authority to the subject matter experts that have context and state. So we let responders make the calls that help them do their job. So next, respect. It's important to make sure that all responders feel comfortable escalating a situation when they feel it's needed. If responders were subject to scrutiny, criticism, or perceptions of ineptitude for escalating incidents, then folks might not escalate when it would be appropriate to do so. And beyond common courtesy, we have to trust that individuals make the best decisions possible, given the information they have in front of them. If something goes awry, the critical issue isn't making someone feel bad for it. It's more important to figure out how to create more accurate and actionable information to make sure that things don't go wrong in the future. So part of this comes during the postmortem process, in which Google maintains a really strict policy of blamelessness. And finally, transparency. We don't silo. When an incident happens, the details therein are mostly made available to everyone. Escalation and interoperability can't happen if we're prohibited from accessing information about incidents. And postmortems written after incidents are shared widely. I lead a company-wide weekly newsletter that features all the incidents that happened in the past week. And we encourage this type of cross-learning that results from reading about incidents occurring on other teams and in other product areas. So, with these factors in mind, let's explore the resolution of the Mayan apocalypse. When we last left off, the original network component on Caller had a lot of friends, since everyone's stacks were being affected by the underlying outage. So with nearly 40 people involved, there wasn't enough mental space for a networking hero to work out the appropriate mitigations, coordinate implementing those mitigations, communicate widely to all stakeholders, and manage expectations. I can do like one thing at a time. We can't expect somebody to do 4. So they escalated. Our network component on Caller paged Tech IRT, and their page reached a number of Tech IRT members within an appropriate time zone, and those available to work on the incident signaled their availability. Now, here's where it was a little different than normal. Because the incident was so broadly reaching, many folks were already involved. Several of our Tech IRT responders didn't take the role of incident commander because they were members or managers of teams that worked on networking and could help address the primary root cause. So they chose to assist with operations instead. Now, the member of Tech IRT that accepted the role of incident commander hadn't previously worked on the networking components that were affected by the failure. But they were able to assess the state of our SOS and assess the state of the people responding to that outage. At this point, there was a lot of stress, a lot of worry, and a lot of fear. But using their regular training, this person accessed our production systems using a mechanism that immediately identifies their actions as incident response. So they were able to subvert this kind of degraded internal traffic flagging. So once there was a little bit of headroom for internal traffic, the incident responder directed that networking on Caller to jump in and make things happen. So while that was ongoing, they quickly imposed structure and organization on the communications happening and on all of those trying to pitch in. So once this frenzy of chaotic engineering energy was organized, everyone started making progress, together. They could more clearly track the ongoing status of different communications. They saw the pace in which mitigative actions were being rolled out. So with this kind of administrivia no longer burdening our network component responder, they and their team who had shown up to help kind of had the space to implement an appropriate mitigation plan. This include shedding a lot of load in order to buy system headroom for a healthy reboot and some emergency forced config changes, essentially beating Maya into submission. Now, once the path forward to mitigate the incident was in motion, that TechIR team member focused on driving the incident towards closure. They set some exit criteria for when we could officially call the incident closed. They made sure that other systems were supported in any recovery actions they needed to perform. And then they made sure that the involved response team could hand off and detach. So after this incident concluded and normal service was restored, an in-depth post-mortem took place to analyze the incident and understand the nuances of its root causes and the emergent properties that were brought to light from these failure modes. So the networking teams involved have since worked on some really cool initiatives to restructure Maya and prevent this failure mode, and similarly possible but not previously considered failure modes from plaguing our systems again. And finally, we rewarded the folks involved. Internal profile badges, honorific memes, bonuses. A really severe incident is, for most, the worst day of your career. So offering something small provides a subtle incentive for everyone to contribute to the postmortem, keep things blameless, and help us learn and grow continually more resilient. So, thank you so much for listening. I have a few people to thank for helping contribute to this presentation. Yeah, now I guess we'll accept some questions. Thank you.